Okay, so today we're working on a 2015 Chevrolet Malibu. It has about 92,000 kilometers. As ABS light is on, service brake assist light is on, StabiliTrak message is on. So we're going to scan this thing and see what it sets for a fault code. I suspect the typical wheel bearing failure, where the magnetic reluctor strip on the inside of the wheel bearing crumbles, falls off due to the salt and the piss poor design that it is. So we've auto ID'd the vehicle, and I'm not going to bother doing a network scan. I'm just going to go straight to ABS and check it for codes. Display codes. C0040, right front wheel speed sensor circuit, signal amplitude symptom 18, current DTC. So we'll have to put this up on the hoist and have a look at the back side of that wheel bearing and see if that reluctor has failed, or see if there's any potential damage to the wiring. Signal amplitude doesn't sound like a wiring problem, sounds more like a mechanical failure. Well, we'll have a look. So here we are under the right front wheel, and looking at the speed sensor in the back here, we can see the actual speed sensor goes through the aluminum steering knuckle, and it registers a signal off the back of a magnetic wheel or magnetic reluctor that is adhered to the back of the wheel bearing. Now if you look in here, you can see this reluctor is just sitting here. So it's literally fallen off the wheel bearing. We'll have a better look at it once we get it out, but this thing needs a new wheel bearing to fix this fault code. So the first step is to remove the right front wheel. Turn the steering all the way to the right. Since the brake pads are in good condition and it doesn't need any brake work, there's lots of brake pad there. Hard to see it. Let's try backing up here. We're going to take the caliper and bracket off as an assembly and then tie it up back here so it's out of the way. Remove the rotor retaining bolt, the rotor off of the hub assembly, the axle nut from the front here, and then there's 3 retaining bolts in the wheel bearing assembly holding the wheel bearing to the actual steering knuckle. So we'll pick up when we get the brake caliper off and the rotor off. So you'll need a T30 Torx bit and maybe an impact driver to remove this brake rotor retaining screw or machine screw. I did it with just a ratchet because this is in good shape. Then a 32mm axle nut socket. I used the impact gun to take it off, but if I was going to do it manually, I would have removed the nut prior to taking the brake caliper and rotor out, and I could have used the brake caliper with a screwdriver or a small bar in the slots to stop the rotor from turning. I don't have an assistant to step on the brake and hold it. So the brake caliper is supported by a reusable tie wrap hanging from the coil spring, and we're going to remove these retaining bolts in here. There's 3 bolts that we need to remove to take the wheel bearing off. Don't need to worry about the speed sensor. It should be fine where it is in the knuckle. So we'll pick up once we get the wheel bearing out of the knuckle. So here's the wheel bearing out, and this is what I was talking about. This magnetic reluctor has literally fallen off the back of the seal. You can see it on the new bearing here. It's adhered to the back of the seal on this wheel bearing, and it appears that the nasty salt that they're putting on the highway here gets in behind this thing and releases the adhesive, and sometimes a piece of this will fall off, or sometimes it'll just completely crumble, and in this case the entire reluctor has fallen off the bearing. The bearing is perfectly fine. You cannot purchase or replace that magnetic reluctor. And here we can see the actual speed sensor. There it is there, that piece right there. And we're going to clean up this aluminum housing and the mounting surfaces and put some never sees on there for the next time we have to take it apart. This actually came apart pretty easy because it's a pretty new car. So I've got the inner race of the steering knuckle, the aluminum knuckle, cleaned. I used a die grinder, but you could use sandpaper. And I've put a layer of never sees on it and the splines. Do not put never sees on the threads of the nut here. It should have Loctite on it. I've got a little dab of Loctite on each one of the bolts. And we're going to put the bearing back in. There is a little metal spacer here that went on here, which is something I haven't seen on other models. So we'll make sure that's in place. I'm not sure exactly why that's there. Like I said, I haven't seen that on other models, but it was in there, so we're going to put it back. Put the wheel bearing on, torque up the fasteners, and reinstall the rotor and brake caliper. So this aftermarket wheel bearing has no relief holes in it. It does have a relief in here, and it does have a place for the mounting bolt that retains the rotor in place. But the back of the rotor is going to have rust spots on it from where it was in these holes on the original wheel bearing. So it's mandatory that you use a sanding tool of some kind or sandpaper to clean the rust off of here, otherwise it may not sit square against the rotor, causing rotor run out and possibly brake pulsation or brake noise. So we're going to clean that up with a angle grinder, the surface sanding disc. So there, that's cleaned it up enough. So no rust in between the rotor and the flange. I used the angle grinder with a roll-lock sanding disc on it to clean it, but you could use sandpaper. It just take a little longer. Well, I wonder when they went to this. Looking up the torque for the 3 fasteners that hold the wheel bearing onto the knuckle. Vehicle is equipped with torque to yield single-use fasteners. Install a new bolt when installing this component. Failure to replace the torque to yield single-use fasteners could damage the vehicle or the component. Now, if this is the case, the wheel bearing manufacturers should be supplying these bolts, I would suggest, when they're supplying the wheel bearing, if they are a single-use fastener. Anyways, I'll have to replace the bolts. The first pass is 74 foot-pounds and then 60 to 75 degrees. That's really convenient, GM. Very nice of you to switch to single-use fasteners. So here's the procedure for the axle nut. Tighten initially to 111 foot-pounds and then 45 degrees, and then a final pass retighten to 184 foot-pounds. So like, why wouldn't you just tighten it to 184 foot-pounds? I don't get these engineers sometimes when they come up with this brainwave. Tighten it to 111, turn it 45 degrees, and then retighten it, loosen 45 degrees. Oh, pay attention, Phil. Tighten it to 111, loosen it 45 degrees, and then retighten it to 184. Got it. Okay, so it's easy to torque this if you use a pry bar or a small pry tool in between the rotor fins and up against the brake caliper so it doesn't turn. Like it said, 111 foot-pounds, back it off 45 degrees, and then tighten it to 185 foot-pounds. So we've done that, and we've replaced the 3 fastener bolts and torqued them per spec, and we're ready to put the wheel back on and clear the fault codes. Okay, so we're going to go into codes menu here and clear the fault codes. Key on, engine off. It already is. And it says if codes persist, try again, key on, engine off, which is what I just did. Anyways, in some cases with some GM ABS systems, you have to road test the vehicle over 5 to 8 kilometers an hour for the system to go through a self-check before it actually erases the codes. This one has erased the code, but I have seen a lot of older GMs where it'll say it's cleared, but if you go back and check, it's still present until you actually drive the vehicle a few feet, and then it does a self-test, system passes, and it clears the codes. We can look at ABS data while we're road testing it, see if there's a speed sensor, but I'm sure it's going to be fine. I did find a TSB on this thing, interestingly, in Identifix. It was under that C0040. C0040, I think, was the fault code. There are 2 TSBs, it says. One of them talks about the speed sensor reluctor becoming contaminated with metal fragments. They're saying metal fragments on the sensor can cause or interrupt the signal, such as this here. Didn't mention anything about the reluctor falling apart or delaminating from the wheel bearing, and this fits a lot of vehicles all the way back to 2007. 2008, 2010. I've done 2011s, 12s. I've done Cadillacs. I've done Equinoxes, Impalas, Terrains, and now a Malibu. So I really think that GM needs to address this problem. Whether it'll ever happen or not, I seriously doubt it.